We are live on YouTube now.
Nice.
Hello, can y'all hear me? Great. So, hi everyone. My name is Akshaj, and I guess when I took WebLab, all the sites, Chatbook, and everything was really cool. But I really took WebLab to learn how to make games because I like playing games. I like chatting. I like live interaction. So that's what I'm going to teach you how to do today. So workshop 8 will be on sockets. So how this is going to work is there are going to be 3 parts to this workshop. One, I'll do a 10-minute recap on a lot of the topics that we covered so far. And 2, we're going to build something cool. You might already know what it is, but I will not spoil the secret yet. And we'll build it using only things that we've already learned. So no sockets yet. And then in part 3, we'll add sockets to whatever we make. And it will be fun. Okay, so let's start the recap. So there's 2 big parts to web dev. It's the front end and the back end. That's how I like to think about it. We got React. How I like to think about React is you got your HTML, your JavaScript, and your CSS, and React just easily combines them. So it's code that generates each of these things kind of matched up. We also made like a nice little document, 3 pages long, very quick, if you guys would like to refer to it at weblab.to/react-guide. If you ever forgot what React is, want like a refresher or need like a quick little cheat sheet type thing, will be very useful. But the main power of React is it allows us to split our website into easily manageable pieces, which we call components. So for example, Chatbook is a very involved website, as you guys all probably know. But if we split it up into different components, then each component is a lot more manageable. So we can split it up. So we got our full feed, the big, this big purple rectangle thingy, the whole page. But we can split it up into cards and the new story part. So we got the new story part right here, where you submit a new story. And then we got a bunch of cards, which are, there's multiple of them, which is nice because we don't have to like rewrite the code each time. We can just use the card component. And then we can go even further, and the card is divided into a single story and the block of comments. And we can go even further and divide the block of comments into one individual comment and then the new comment button. And outlining it all in a tree like this is kind of nice because, as you guys all probably know, if you just stare at the VS Code and the list of all the files, it's kind of like, oh my God, there's so many files. It's very hard to keep track of everything. But a tree lets us clearly see what is nested in what, and it's very helpful. So I guess a common question that I've heard a lot, and it's also a very important question, is how do you actually get started making an app? Like, you got your idea, but all the workshop we've done have had starter code, and I guess for all your projects, you're kind of starting from a blank slate. I guess you have the skeleton, but other than that, it's from a blank slate. So what I usually think is a good idea is to draw out your own component tree like this with like arrows to see what is a parent of what and what components can be split up into what other components, and then write out the props and the state of every component. Like the props are like things that are passed from one component to their children. So I guess this is really clunky. It's because I'm bad at drawing things in PowerPoint, but it at least gives like some sort of overview of how the props go from one place to another. And it can help you guys stay organized before you even start coding by making a tree. Okay, so now let's get to some JavaScript important things. This is not, map I would not say is a React thing. I guess it's more of like a plain JavaScript thing. But so if you guys remember how map works, it basically takes an array and it takes a function, and you apply the function to every element of the array, and you get a new array. And it's used a lot in React because we often we want to make like a list, like we want to make like a list of stories, but we have the story information. So we have to map the information to a component. That's why we use map. So if we use a real world example, we can have like a list of turtles, and then we can map to the function of putting a hat on the turtle. And okay, this function takes a turtle and it checks if the turtle name starts with a B. And if it starts with a B, it will put a hat on the turtle. Otherwise, it will not do anything to the turtle. So what will happen is the function will like go in order from Alfred to Billy to Charlie to Shannon to Buka Buka to Floppy, and then apply the function to each one, and we'll end up with, you can guess, we'll end up with Billy and Buka Buka having hats because they start with the letter B. Okay, I will let you guys try to figure out this one. So do you remember what filter is? Try figuring out what this filter and map does. I will watch the chat to see. If there are any guesses. Yeah, so it only returns Billy and Buka Buka, just like the previous example. But the difference with filter is that it deletes everyone else. So I guess the thing that filter does is how it works is it looks at every turtle in the array, and then it applies the function that it takes the turtle and returns, do I start with the letter B? And what this checks, so it's a function that returns a Boolean. And how filter works is it keeps everything that the function returns true for, and it deletes everything that the function returns false for. So it will delete everyone except for Billy and Buka Buka. And then we'll apply map, and map will put a hat on both of them. So we're left with these two amazing turtles, Billy and Buka Buka. These graphics were not done by me. They're very good. Okay, so now we are going to figure out how to talk to the backend from the front end. This is important because this, like, the front end and the back end are kind of two separate things in the code. There's like the React is the front end, the API.js is the back end, and you need some way to communicate. And the way we do that is through get and post requests. So this is an example of a get request. You have your endpoint right here. I don't know if you can see my mouse, but this thingy right here. And then you got your parameters, the things you pass into the get request. And then this whole chunk right here goes and talks to the server and comes back with a response. And it comes back with a response, maybe all the songs from the server. Shout out to the people trying to use the Spotify API. Songs, you'll get songs from the server maybe. And then after that happens, you will do something with the songs. For example, you might set the state to be the songs from the server. So yeah, that's how you talk to the backend. Okay, this is also kind of important to understand. You got your functions, you got your constructor, you got your component did mount, you got your render, but what happens when? Okay, so anyone have any guesses of what happens first? Yeah, the constructor. And then it's a little tricky what happens next. I always thought for the longest time that component did mount happens next, but actually render happens once next. Let me just show you the next slide. So render happens once next, and then component did mount happens. And component did mount, usually you'll have all your get and post requests there. So it will send the requests, but not really do anything until it gets a response back. And when it gets a response back, it will set the state. And then the cool thing about render is it will happen again whenever the states or the props change. So whenever you do this.setState, it will re-render. So it will happen very many times for the rest of the component lifecycle. You will have render being done many, many times. And then the last, I think it's the last front-end topic, is the router. And the router is great because we like to have different paths on the URL. Like lots of sites have /something/something. And your app needs to know what page to show depending on what the URL is, because you don't want this to show the wrong site. So the router lets us find the path and then render the right component based off of that. And sometimes we have this little parameter thingy here, user ID, and it lets us access like a random string that could be in the URL as a prop. Okay, perfect. Now let's move on to the backend. So for the backend, we got our servers, and they're the central brain of the website. And all the React, everything we talked about so far, runs on people's computers. So all the users of your website will have their own React code running on their computer, but they all talk to one server. So there's one server probably deployed on Heroku, which we'll talk about in a future lecture. But that's where all the computation usually happens for your website. And before you write any code, the server does not know how to do anything. And the way you teach it to do things is by writing endpoints. And endpoints look kind of like this. So you tell it when you hear /stories, you do this thing. When you hear /story, you do this thing. When you hear /comment, you do this thing. And then the server is very happy because now it knows how to respond to things. And when the clients ask it to do certain tasks, the server can respond because it has this little dictionary thingy that it can like check what the path is, and then it can perform the correct action. How do you tell it to go to another endpoint from the backend? I don't even know if that's possible. There's got to be a way. Someone in another staff can try answering that. But usually it's just the client asking to the server, and then the server responds back to the client. And then we got our databases. So sometimes we have a lot of data we want to store, and we can't store it all in the server. So we store it on MongoDB. So when the user submits a new story, it gets sent to the backend. And then the backend doesn't want to store it in the server. So the backend goes and talks to MongoDB and sends the new story to MongoDB. And the way we do that is by using little snippets of code that can be found in web.lab.to/Mongo-snippets, which is a very, very beautifully formatted page that explains MongoDB. And even if you don't need help with MongoDB, I think it's still worth to look at because of how well it's made. But you should check that out at some point. We also have schemas, which are very important. It's how we tell the database what the objects kind of look like. So like a story would have a creator ID, a creator name, and content. And this is also something you can plan out before you write any code. What schemas would you need for your web page? What things are you trying to store? And information about how to write these is also in the Mongo snippets page. Auth, we had a lecture on auth yesterday. I think the most important takeaway or the biggest thing that you will use in your app from auth is this rec.user thing. And the cool thing about rec.user is whenever you make a request from the front end to the back end, on the back end when you're dealing with a request, you have access to this thing called rec.user, which gives you information about the user who sent the request. So when a client posts a story, they don't need to pass in their own name as a parameter because you already have access to it using rec.user. And it's useful because this way people can't fake their names. So like if we took in the user's name as a parameter, they could put in a different name than they actually were, and that would be bad. So yeah, our updated view is now we include some authentication from Google. And it's very nice because Google makes sure everything is very secure, safe, and sound, so we don't have to worry about authentication. Great, so we are done with the recaps. Amazing. Okay, so now to move on to part 2. Sorry, give me a second. I have a Zoom phone call. I guess I have to pause the lecture to respond to this. Hello?
Great job, web.lab. Great job, web.lab. Chatbook is very popular. Unfortunately, our cat stoomers are mad that you have to refresh the page to see new stories. They want live interaction, and cat. Oh, oops, I meant to say chat. Haha, simple mistake, cat and chat, ha ha ha. Please make something for them.
Akshaj, unmute.
Did I mute it? Did I give the whole lecture muted? That would be sad.
We had you before.
Okay. Yeah, so CEO calls are always very unfortunate. But yes, I guess our CEO has a point. Like for Chatbook, I guess a problem is we got all our posts, right? Like, here, let me log in. Oh no. Okay, I'm logged in. And it's very cool. We can comment. Let me check commenting. And we see our comment. But if one of you goes to the site and makes a new story, I'm not going to see it. I have to refresh the page to see it. And that is not very good according to our customers of Chatbook. So we're going to have to change this up a bit. So let's try making Chatbook. So yeah, this is Chatbook. Let me show you guys what Chatbook looks like. We're going to make this, and it's a live chat website. I'm going to chat Nikhil right here. Hello. Hi, Nikhil. Oh my God, Justin just came online. Hi, Justin. Wow, lots of people are showing up. Let's see if we can see some live responses. Nikhil said hi. Nikhil, say something else. I want to show a live response. It's going great. Okay, so yes, we are replacing Facebook Messenger. Isn't that amazing? And we got this all chat right here where you can talk to everyone. Hi. And you can literally see their responses live. I feel like that's so cool. And you can imagine how this would be very useful in a game because you want to see people's text live or whatever they're doing live. And it's not something we know how to do yet, but we will do it today and tomorrow. Okay, so this is our component tree for Chatbook. We got our feed, we got our profile, our not found, amazing. Yes, we can recreate Among Us now with sockets. It'll be very fun. And now, over the next couple of days, we'll add Chatbook. And this is what the component tree for Chatbook will look like. So let's plan this out. Whenever we make a site, we gotta plan everything before we jump into the code. So, oh yeah, also, I think these plans will be useful during the actual workshop part because it's always nice to refer back to the plan. So feel free to open the slides or something, and maybe not yet, but eventually when we get to the workshop part. Okay, so Chatbook looks like this, as you guys saw, and we're gonna divide it into components. So our next division will be the list of open chats, and the actual chat window place. We're actually not going to do the chat list part today. We'll do that tomorrow. So today we're only going to make this thing, but it's still great because we still get a group chat where we can chat with everyone live. I feel like that's pretty cool. And we can further divide chat lists into single user, as you see. We can further divide chat into one message and the new message place. So let's talk about the props and states. I also like to plan out the props and states before jumping into any code. I think it helps. So here's how we're going to do it. We're actually going to store all the state in the top level component, which is a thing that it's a common pattern, I would say. So we're going to store this thing called active chat in Chatbook. Remember, Chatbook is the whole page. And what active chat will be is it will be a list of messages, so like an array of messages, and a recipient, which will be a user. So for example, here, these are the list of messages, as you see. And then the user is all chat. I know, all chat is not a real user. However, we're gonna make all chat a dummy user because like everything else here is users. So all chat will be like a dummy user that we create. But yeah, and if you think about it, that's really all we need in this state. We just need a list of messages and who we're chatting with. So that will go here. Yeah, okay. We do also have to keep track of the people online. That will be a tomorrow problem because we're not doing this part today. So Nikhil can help you guys with that tomorrow. But for today, this is all we need in this state. And then in these sub little component thingies, since all the information is up here, it only really needs to be read-only down here because like all the actual stuff will be happening in here and these things will just be displaying the stuff that's up here. So these can be props. We can just pass down all the information as props. So we'll pass down everything down to chat because everything has to be rendered in here. And then further we'll make a bunch of single message components and pass one message to each of them. And then we'll pass the recipient to our new message component because we need to know who to send the message to. So that will go down here. Perfect. This will be important to refer back to, I would say. And let's talk about our backend plan. So for the backend, we only really need 2 endpoints because we're only doing 2 things if you really think about it. We're just, when they come onto the web page, they need to get all of the messages to show, right? And then when they click submit, they need to post one message to everyone. So those are really the 2 only things that the server needs to know how to do because those are the only 2 things the client will ask the server to do. So yeah, here's an example of clients asking the server to do these things, and our server eventually will be able to do them. And yeah, this tomorrow thingy is tomorrow we'll want to be able to get all the messages for a specific user. So like when I open my DMs with Nikhil, for example, we want to get all the messages between me and Nikhil. So that will be a tomorrow thing. For now, we'll just get all of the messages because we're making all chat, the group chat on the web page. So yeah, to recap, this is our front end plan. It's a very nice little props and state here. And this is our back end plan. Front end plan, back end plan. Great. So now let's actually make it. Great. So I put these little reminder things here because when I dry run this lecture, I always forgot to do these. So you don't have to do this yet. I'll just do it. Okay, let's git fetch, git reset, hard. Check out the starter. Let me drink some water real quick. Yes, I realized I have to charge my computer. Okay, let's make Chatbook. Step 1. Okay, so let's start with the front end. That seems like a good idea. Let's start by making this thingy right here. So we're going to hard code 2 messages. These are just hard coded messages. We didn't actually talk to the server or anything. And we're going to make this input box. And when we click submit, it will just log it to the console. And I guess the advantage of this is now you can chat with yourself, which is still a decent web page, even though it is not what we want. I think it still has some functionality. Oh, also, if you want to see those front end and back end plans, you should go to this link, weblab.2/chatbookdocs. Having that open will be helpful during the workshop. Okay, so step 1, you guys can just watch me do this. These pop-up things are very confusing, I know, but it's just for my reference in that this is the order that I'm going to do step 1 in. So let's dive right in. I'm going to start with new message, and we're going to write the front end for this. So let's go to the code. Let's go to the new message. Did you remember new message is the part where you type in a message and hit submit. So the way we're going to do this is we're going to use a component that we already wrote called new post input. It's very nice when things have already been written. All the new post input is also, can you guys see this well? Is it zoomed in enough? Nice. So yeah, it's just an input and then a button that has submit on it. Oh, I can make it a little bigger. Command plus, does that work? So yeah, it's an input and a button. So we're just going to use it. So new message is right here. We're going to use it by typing new post input, default text. It takes in a prop called default text. You can like scroll up to see the props. And it takes another prop called on submit. So what do you do when they click submit? And we're going to make this a function called this dot send message. And send message is a function that we're going to define right here. And it will take in the message. And we're just going to console log it. Nothing too complicated, just console log the message. Great. We're done with new message. Very simple, because a lot of the code was pre-written, but we just use the component, so it's very nice. Let's move on to single message. So that's one of these single messages thingies right here. Let me find where that is in the code. I've also been training my typing speed a lot for this lecture, by the way, because I will have to do this quickly. I'll just speed type this right here. Bam. Okay, that was very nice. All this is div with some nice CSS, and I'll hide the file explorer. How do I hide this? Oh, perfect. So this is a single message right here, and it takes in, if you remember the props that were passed down to single message, it's in your Chatbook docs. One of them is, actually it's only the message. So we're gonna look at the message prop, And in the Chatbook docs, it tells you what a message looks like. And a message is an object with a sender and content. So we're going to get the sender. And we're going to get the sender's name because the sender is a user. We're going to put a colon. And then we're going to put the content of the message. Perfect. Okay, moving on to the next step. So we did new message. We did single message. Now let's do chat. You remember, chat takes the messages and the recipient as props, and we're going to have to pass them down to single message and new message. So chat's going to have to make components for a single message and new message. So let's do that. Let's go to chat. I'll use my typing speed to type this. So all this is all these class names are just pre-written CSS, and we're going to put chatting with the recipient's name because we're indexing into our prop, and we're getting the recipient attribute, and we're getting the name attribute of the recipient. And then we're going to take the messages, which is also a prop, or it's an attribute of the data prop. And we're going to use our handy-dandy map function, if you remember that. And we're going to map each message to a single message using the single message component. If you remember, when you put in 2 parameters to the map function, the second one is the index. So this is an array, and I will just be 0, 1, 2, etc. So wait, I would actually suggest you don't follow along your VS Code, by the way, because I'm probably going way too fast, considering my typing speed is very insane. So I'm basically copying and pasting code. So I don't think I would be able to follow along by typing. But OK, so when you put in the index, when you put in a second parameter to the map function, it just gets the index. So it will be 0, and then it'll be 1, and it'll be 2 for the next message, etc. And we're passing it into the key thingy here, because if you remember, when you do a map and get a lot of single messages, you want to distinguish them somehow. So you'll put that in the key. OK, great. We got our messages. And then we need our new message thingy, the place where you type in a message and hit submit. So we'll just create a component for that, and we'll pass in the recipient prop that we have from our prop. So we're like the middleman. Chat is the middleman in this scenario because it takes in the stuff from Chatbook, which is its parent, and passes it down to single message and new message. See, chat is the middleman right here. Chatbook sends the data to chat, and chat just sends it along its way. Yeah, so this is amazing. We did 3 out of the 4 components already. Very, very nice. OK, so this is the big component right here. So let's tackle that. OK, so I'm going to go to Chatbook. I've always had trouble finding where Chatbook is on this list. Oh, it's right here. OK, so let's write the code for Chatbook. See, this is the Chatbook component. I did not lie to you. It's Chatbook. It says that right here. So in our render, let's return Chatbook. And also, if you remember, Chatbook is basically just the chat part, because there's also the chat list on the side. See this chat list right here, and then the chat. But the chat list is the tomorrow problem. So we're only going to put in the chat. So we got a chat here. And we're passing in as a prop the recipient and the messages, which is our active, it's our active chat thingy. Remember, active chat is the state. So we're passing that in. But we're actually just going to hard code it. So we're going to define these variables, all chat and test messages, just up here. We'll just hard code it. Getting my typing ready. Yeah, okay. So test messages is just like a bunch of little dummy messages. And all chat is just a dummy user, because remember, we're making all chat be a dummy user because we want to chat with specific users, but everyone should also count as a user. So yes. And voila, I think that should be it. And now I can actually go to localhost 5000 and I can wait for it to log in. And then I can go to chat and we have our hard-coded messages, very nice. And if I inspect element, I can type in a new message. Hello, oh, that was people. And it just console logs message. Yay. Okay, back to the slides. So that was a lot. I apologize for how much that was, but it was step one. I think it was by far the longest step. So now let me do a quick poll in the chat. Would you guys prefer me to do the next step or you guys to try it on your own for a bit? Out of curiosity. No, I wanted y'all to try it for a bit. Okay, I'll do it, fine. Yeah, I really apologize about the speed, but okay. We're not at the socket part yet, so this is just setup. Okay. So, yes, so let me go to the next step. So, okay, so the next step is to change the state. So if you remember, we kind of hard-coded the chat messages, right? And we're still going to hard-code the chat messages, but we want it to actually be a state. We didn't define a state at all at any point. So the only change that step 2 is to make active chat a state. So here, let me make this more clear. So active chat, if you guys look at the Chatbook docs, you'll see active chat is the list of messages and the recipient. So in order to have this be a state, we got to go into Chatbook and we got to do this dot state right here. And let's set the active chat attribute to be, let's set the recipient. So this value right here, when we put in a value in the constructor state, it's just initializing it, essentially. That's how you can think about it. So we'll just initialize it to be the dummy stuff. So the fake messages and our all chat user. And now instead of permanently being these dummy stuff, it's just initialized to be the dummy stuff. And now we can use this .set state to change active chat. And when we do that, it will re-render. So it's just hard-coded at the beginning. It's not permanently hard-coded. I think it would be wise to pause a bit. I think maybe I can try answering some questions if you guys have any. But yeah, what we've done so far is we've coded the front end for new message. We've coded the front end for single message. We coded the front end for chat. These are all just taking in props and displaying them, basically. They're not doing any fancy state stuff. And then Chatbook, we're just hard coding some initial information into the state. And that's it, yeah. Okay, how can we pass state as prop if private? Yeah, so that's a good question. State is technically not private. I guess private is a word that we used because you can think of state as like information specific to a component, but oftentimes you want to use it in the children. So the way we do that is we pass the state as a prop. And that way the Chatbook's children can use the state wherever they want. Yeah, no problem. Is it copied over or is it passed by pointer? It's read only. So I guess I haven't really thought about that, but you can't change it. So either way, like I guess the main distinguishing thing between those two is that you can't. It would be how you change it and what happens when you change it, but either way, you can't change a prop. You can't change a prop in the place where the prop is passed to, if that makes sense. So like chat cannot change this prop right here. Single message cannot change this prop. So either way, it's just, you're basically just using them. You're not changing them. Yes, it is read only. Okay, I'll move on to the next step if that's okay. I had that slide, the Git checkout one, but I still didn't do it. So I guess I'm just very forgetful. Let me do that. Git reset --hard. Git checkout W8 step 1. It's probably 2 now. Yes, this is the instruction slide for step 2. Okay, so we have gotten onto the same page. Step 3 I plan to do, but I'll make you guys do step 4 because we skipped over step 2. Okay, step 3. So we kind of tackled a lot of the front end in step 1. We went very, very fast, but we did get through all of the front end components. So we should start writing the back end, I would say. So there's 3 main components in the backend. First is we got to write the schema for what a message looks like because our server doesn't really know what fields we want a message to have. And then we want to write each of these 2 backend methods. So let me go back to my code. So let's do those 3 things. So step 1 was add a schema. So it's always a struggle to find the place in the, oh, it's in server. So let's write a schema. Again, my typing speed is impeccable. Okay. I know Command P is to search for files, but I still never do it. I don't know why. Okay, so our message, the important things are sender, because we want to know who sent the message. And sender will be a user object. So a user has an ID and a name. We also want recipient. So we need to know who sent it. We don't want to know who's receiving it. For purposes of this lecture, recipient will usually be all chat, because all the messages are going to be sent to all chat. So what we're going to do is we're just going to make the ID the string all chat. I think it's like something like this. And we're also going to make the name all chat. But when Nikhil gives his lecture tomorrow, we'll actually have real recipients, because we want DMs. And then we'll have the content of the message, the actual text. And we don't have to do this, but it's nice. Like typically in a chat app, you want to see when people send a message. So we can store the timestamp of the message. Seems like a reasonable thing to do. And this default thing is basically setting a default value if we don't specify it, because we won't specify it. Okay. Perfect. And then let's go to our API. And let's write our two endpoints. I'm probably going to go kind of fast through the rest of this like setup stuff. I apologize. I just have to eventually talk about sockets. So that's the meat of this lecture, I would say. Let's write this message route. So let's do router.post message auth.ensure login connect res. And I'm going to put this console log so we can see it log in the console that we received the message. And then after that, we're going to, oh my God, clearly I can't type. We're going to make a message object. So the way we do that is new message. And we're going to pass in a recipient, which is going to be taken as a parameter. We're going to pass in a sender, which will have an ID, which we get from rec.user, which is our auth thingy. Remember, the thing that's very important to know about auth is that you can use rec.user. And then we want the content of the message, which will also be a parameter. And after we create this message, we want to save it. And the way we save MongoDB messages is we just type the message .save. Nice. And okay, we want to do our other thingy, our other endpoint. So let's do get request. And if you look at the Mongo snippets, it will tell you how to get all the messages with a certain recipient ID. And the way we do that is we use the .find, and we can do recipient.id is all chat. And that will get us all the messages that are sent to all chat. And that's what we want to return. And then this is actually a promise, so we can do a .then. And res.send messages sends it back to the front end. Okay, that's step 3. So we have done this. We have defined what a message is, and we have written the backend for the 2 things that we need the server to know how to do. Great. On second thought, I think I'll try to do step 4 because, okay, I apologize that I haven't been letting you guys work on any of the steps, but I think I'll let you guys work on the last step. I'll make a deal. Okay. Okay, step 4 is completing send message. So, okay, let's think about what we've done so far. We wrote all the front end stuff. We wrote all the back end stuff. But the only thing we need now is to connect the front end to the back end. So the server knows how to respond to all the requests. We just need the client to actually make the request. So let's go to the client, and let me find the client. I know, Command P, yes, this exists, but yes, I like searching the easy way. Okay, so here is our submit button. And right now we just console logged. So let's actually submit. That would be nice. So we're going to write a post. And we're going to use our message route. And we're going to pass in a parameter. And if you look back to api.js, you'll see that we assume that they pass in a recipient. And we pass in content. So what should we put here? Well, the content of the message is the value, because that's how onSubmit works. But who's the recipient? Well, if you remember, we pass in the recipient as a prop to new message. Also, by the way, whenever I say if you remember, there's no way, it's like impossible to actually remember this. So what I really mean is, if you look at the Chatbook docs, then you will see where the props are passed, and you can see that the recipient is passed to the prop. This .props.recipient. The only reason I remember it is because I have an answer key in front of me, which is very nice. Okay, so this line of code is actually all we need, because it just posts to the database. Sorry, it posts to the server, and we just coded the server. We just told the server how to respond to this. So that's already taken care of. We just needed to make the request, and it's all good. So this is done. Let's get on the same page. I'll get on the same page with the slides. Git reset hard. Git checkout. 28, step 4. Oh, yeah, wait, let me show you guys what we've done so far. So, oh no. Yes, okay. So we made it so that now when you type a message, let's see if this works. Well, we got rid of the console log, but what we added is now our terminal where we ran npm start said, receive the chat message from me. Let's see if this works. So we actually posted to the server. Nice. However, if we refresh, nothing will happen. And that's because we hard-coded the messages. So the last step is to not hard-code the messages. So we got to take advantage of our last little thingy, our last little endpoint. So let's do that. So if you remember, there were two endpoints. We just used one of them in step 4. So we're going to use the other one. So let's go to Chatbook. Every time I scroll the wrong way for Chatbook. Okay. Make this smaller. Okay, so basically, when a user comes onto the site, we want them to see all of the messages. So to do that, we got to put in the component in mount, because that's what happens at the very beginning, if you remember the life cycle. It's like it does the constructor, and then does the first render, and then does the component in mount. And that's where we put all of our post and get requests. So we'll put our post get request, which is going to go in a function. We're going to load the message history. And this will be a function that we define right here. And let's load the message history of all chat. Meaning, we'll get all the messages that were sent to all chat of the recipient. So the way we do that is we do a get request. And we'll pass in the recipient ID, because that was one of the parameters that we used in the backend. And the recipient ID is just, we have our recipient user object right here, and we'll just index to get the ID. And that's not it, because we're getting it, and we have to do something with what the server sends back. So to do that, we use the .then, and we have our messages. And we want to set the state to be this .set state. Active chat. So we're changing active chat. If you remember, active chat is basically the only state in the whole app, in the whole chat book. And it is the list of messages and the person we're sending the messages to. So we want the person we're sending the messages to be the recipient, the same recipient who we're loading the message history for. And we want the messages to be these messages that we just got from the server. And that is it. And let's see it in action. I'm going to refresh. Always scares me when this odd thing happens. Wow, we just got all the messages from the database, from the server. Very nice. From all the years of web.lab history. Okay, so we're actually done with this section of the lecture, because this is a fully functional chat app. We can like type a message, hi, and then we have to refresh the page because we have to get all the messages again. And we see hi, and Karen just said hello within the time that I refreshed the page. Very impressive. But yeah, we have to refresh the page each time. And that's not what we wanted, because if you remember, our CEO had some different ideas. They wanted live interaction and no refreshing the page. They wanted things to appear instantly. So let's talk about that. Give me a water break. Okay, it's time for what you came for, sockets. How do you make this in real time? Okay, so basically how this works, or how we want it to work, is the client sends a new message to the server, says meow. And then the server should tell all of the other clients, hey, Fluffy just said meow. And then the other clients would just update it in their client. And we'd be done. Damn, that was so easy. Very, very simple. Just say meow when the server tells you to. That would be very nice, but it does not work that way. And the problem is, server is a type of human that can't initiate conversations. What that means is that if the client ever talks to the server can respond to that particular client. But the server cannot initiate conversation with any of the other clients. So that's a problem, because if you're relying on the server to communicate with other clients, like the server would not be able to tell the other people what you just said. So that's a very, very sad problem. And there is a solution that we can think of to this. And the solution is, okay, imagine you have a group of friends and you're trying to communicate with each other. So how you do it is, the first one of you tells the server your message. Hey, I want to say hi to everyone else. And then every 2 seconds, every single person asks the server, hey, are there any new messages? And the server says, no, nothing yet, to every single other person. And this happens every 2 seconds until the server finally has a message for that person. And then the server will tell him the message. So Jeff has to ask the server every 2 seconds to see if there are any new messages. The reason we have to do this is the server cannot initiate conversation. So the clients would have to initiate conversation every 2 seconds. And this is indeed a solution that could lead to an app, because it would work. Like, there's nothing that doesn't work about this. However, it is very inefficient, because we don't want to be continuously asking the server something every 2 seconds. Imagine if you had to talk to your friend and the way you did it was by asking a third party if your friend had said anything in the last 2 seconds, every 2 seconds. I think that would be very inefficient. So now the reasonable question is there a better way? And the answer is yes. And the way we do this is through sockets. And you're going to be mad at me, but the solution is to just teach the server how to initiate conversations. Yes, a very, very dumb solution. But indeed, we can just teach the server how to initiate conversation. And that makes it so much simpler, because now you can tell the server something and it can just tell everyone else. So yeah, that is what sockets do. Very powerful. So there's a small caveat, and I think oftentimes the server is a bit slow. It needs to learn things in like a step-by-step manner. So we won't teach it how to initiate conversations fully today. Tomorrow we'll teach it how to initiate a conversation with a specific person. Today we're just going to have the server shout to everyone at the same time. So whenever you have something to say, you will tell the server the message, and it will shout to everyone that message. And then people can choose whether or not they want to listen to it. But indeed, this is a way that you could have a conversation in theory. You could tell it to a megaphone, and the megaphone would shout it to everyone, and you could converse. So yes, the server sends the message to everyone. Nice. So I know I've been talking in analogies for very long, and you're like, okay, we get it. Just get to the code. Okay, I'll get to the code. So this is the code. How it works is, so we wrote this thing called Socket Manager for you. And Socket Manager, if you're curious, you can look at it in server socket.js in the skeleton code. It's also in Chatbook. But you don't need to. It's not like extremely important to understand or anything, because you can just use it in the ways that are allowed. So one way you can use it is to shout to everyone. And the way to shout to everyone is type in socketmanager.getIO.emit, the title, and then the data. So any shout, you need to title it with some string, and then you can shout some data. So data can be an object, a list, a string, anything. But how like, if you would do a message, then maybe you could shout, hey, I have a new message. And then the data would be the actual message. So the title is just like a short descriptor type thing. Yeah, you can use that manager for any real-time app. It doesn't have to be a chat app. And then we actually need to tell the client how to listen for the message. So the way we do that is using the socket.on thing. This will typically go in the component did mount. And the way we use it is we type socket.on, and we put in the first parameter is the event name that we're listening for. So when we hear the server shout, new message, we got a new message, then we have to do some function. So the function will take in the data as a parameter. So it will be passed in the data of the message. And typically we'll do something with the message. So in our chat app, we'll listen for the new message event. And when we hear it, we'll take the new message and we'll add it to our message list. And that's it. You just have to understand these two things, the shouting and the listening. And using shouting and listening, you can make a conversation happen between the server and the client in real time. So let's go over a toy example per se. I know I'm getting back to analogies, but this one has some code, so it's okay. So imagine you have the professor, and the professor is a server. And the professor emits, meaning it shouts to all of the students, hey, there's a new p set. And then it passes in the p set as an object. Then the students would need to have a socket.on in their component did mount, and they would listen for the event new p set. And when they hear that event, they would apply the working function to the new p set. So this is how it would look in the code. You would have your socket manager.getIO.emit, the new p set. This would all be in the server in api.js, because the professor is the server. And then on the client side, in the student's component did mount, they would listen for the event new p set, and they would do the p set. Or they would apply some function to the p set, which is typically procrastinate until it's due and then solve the questions. So yeah, this is another diagram explaining how sockets work. You just shout the message with a title usually, and then the clients listen for the message. They listen for the title, sorry, and when they hear the title, they apply a function onto the data that they receive. Okay, so finally what you're waiting for. We're gonna add live interaction and live chatting to Chatbook. Okay, I will give you guys, I guess 5-ish, maybe more than 5 minutes to try to figure this out. So finally it's your turn. But this is basically like all of Socket. It's not all of Sockets, we got stuff tomorrow, but this is taking the website from no sockets to fully working in the sense that you can chat and see things live. So this is a lot of functionality that's going to be added in this step. So let's go back to, this is something that you guys can do with me. I'll give you some time to work on it. Let's get reset -- hard, git checkout w8 step 5. And if I can show you the next slide. So step 6 is going to be add sockets to see the messages instantly. So I put the line numbers that you will have to change here. There's 2 instances in the code that you'll have to change. One is the shouting, when the server shouts to everyone. And the other is the listening from the client. So the shouting will just be look like as like every single shout will look like this. It will be socket manager.getIO.init. There'll be a title. You can make the title whatever you want. It's just that these 2 strings have to match because you got to listen for the title. And then you put in data, which will be the message that you just made. And then on the front end, you will listen for the title. And then you will take in this text, by the way, it can be any, like, it's just a variable. So this could be message, this could be data, it can be anything. But like, you will take in whatever was sent as data, which is the message, and you'll do something to it. And what you'll do to it is you'll add it to your current message list. So I'll give you guys some time to, if you want, you can go to breakout rooms or you can stay here and hopefully you can see a live message app work. Good luck. I'll play some music maybe. I can also answer questions in the chat if you have some. Hello. Yeah, I don't know how to broadcast to people in breakout rooms, but maybe Kai can figure out how to get them back.
Wait, do you want to bring people back?
Yeah, do you know how to do that?
Wait, if you open breakout rooms on the bottom, there's a button that says broadcast to all.
Broadcast to all. Isn't there like .emit or something?
Huh?
Nothing. I can't find it. Oh. I'm shouting to everyone in the breakout rooms. I feel like a server. That's a joke that the Chatbook CEO would laugh at. Okay, hopefully people are back. Yeah, so I guess it's not that satisfying because remember the server is on your own computer right now. So you won't like see other people's messages because it's your own server. But I guarantee you, if you take your code and deploy it onto Heroku, then it will work and you will be able to see everyone's messages live. So the code is all correct. Okay, so let me show you guys how to do this. Okay, so that step actually wasn't supposed to be one that I asked you guys to do, but I just thought it would be a fun thing. So there's two things we got to do here. We got to shout and we got to listen. So let's do the easier one first. Let's shout. So let's go to api.js. And when we post a message, so in our post message thing right here, remember we save it to the database, and now we're going to shout. So we're going to type socket manager.getIO.emit. The title would be message, and then we'll pass in the message. Great. That's the easier half of the equation. The harder half, and I think it was probably not obvious what to do in the listener, but thankfully we have an answer key, so I can just show you guys what it says. So in Chatbook, all the socket.ons go in the component did mount. So that is a good thing to remember. So we're going to put a socket.on right here and listen for the title message because that's the title we gave to our shout thing. So we're going to listen for this title, and whatever data we get, let's call it message, because we're going to get one message. And what we can do is we're going to set state. Let's use the pre-state thingy. The pre-state thingy is when we pass in a function to this set state and takes in the previous state as an input. And we can set active chat to be what we want it to be now. So what we want it to be is the recipient should just be the previous recipient. It's not like the recipient changes when you get a new message. So because we're still looking at the same chat. So we want the recipient to be the same one. And then the messages are the old messages. These are all the messages that already existed. And we want to concatenate it with our new message. So we want to add the new message to the end of this list. One way to do this is use the .concat. We just concatenate the message to the end of our list of messages. Spell messages wrong. Feel like, oh, I think this needs parentheses or something. Yeah. And that's it. We just needed to update the state to be the new thing that it's supposed to be. So the only change to the state, it used to be a recipient and a list of messages. The only change is we add one message to the list of messages. And what this lets us do is we can reload the page. And I'm going to log in. Remember, this is still local. So in order for it to be like a public chat site where we all can chat, we would have to deploy it somewhere to Heroku. But for now, this is just local. But I can chat with myself. And if I make like a incognito tab and logged in with a different Gmail, I could, or like I opened a different browser and logged in with a different Gmail, I could chat with myself and see it live. Or this is live. Go and hit submit. And it appears. Perfect. So yeah, that's Chatbook. I hope you guys enjoyed seeing how sockets can be used. The two big takeaways from this lecture are the shouting and the listening. So the .emit and the .on. So knowing when to use the .emit, when to use the .on, where they go. I think those, if you understand that, then you know how to use sockets. So I don't know if there are any announcements before lunch. You all are probably hungry. If anyone has any announcements.
Just on sponsor lectures, we have 2 sponsor lectures today. The first one is from Facebook. It'll be at 3, and it won't be recorded, so make sure you're here live. They'll be talking about data management and using an API or a library called GraphQL. And then after that, we have another one at 4 p.m. from Gather. And Gather is actually going to be doing a workshop on building real-time games. So if you're curious, if you're implementing a game, if you're curious about that, definitely do that. Also, yeah, we have a YouTube channel for the class. We're almost near 1,000 subscribers, and once we hit 1,000, we can monetize on our account. So go to, I hope this doesn't get us in trouble if I announce this, but go to weblab.2/YouTube and hit that smash the subscribe button.
I've always wanted to say smash that like button.
Yeah, I think we'll be back at 3:05 for Facebook's lecture.
Okay, see you guys. Have a good lunch.
Hey, folks. Can you hear me?
Yeah. Hey, Oscar. I think we're probably gonna start in like 10 minutes. Students are on the lunch break right now.
Sure.
So we'll probably start around 3:05. But yeah, and I'll kind of introduce you, and then once the students get back, we can get started.
Yeah, sure thing. Just wanted to check like video and audio were good to go.
Yep. And then what else was I say? Oh, and I think we're just waiting on Ben as well. But yeah, feel free just to hang tight for a bit.
Perfect. All right, I'll be around.
Cool. Thanks. Hey Ben, we're probably gonna start in like 5 minutes. I think the students are coming back from a lunch break right now, and then we'll get started.
Sounds great. Thanks, Nico.
Mhm. Is Shannon there? Or... No, Alex is here.
Hello. Is Alex here?
I
I'm
saw
here.
him.
Hello. Okay, great. This is our sponsor, Alex Chen. He's going to be representing Gather, which you've all used for Milestone 1. Alex has been on staff the last 3 years, so he's an old staff member. He was my TA when I took it as a freshman, and then we worked at Gather together. But he's very excited to teach you all about games. So if you're building a real-time game, you should pay attention because this will be very helpful. Yeah, Alex, take it away.
All right, thanks, Shannon. Hey guys, it's great to be back at WebLab. This is a super awesome class, and I really miss it. So I'm glad you guys are having a fun time. But yeah, like Shannon said, today we're going to be covering a little bit about game development. I'm going to share my screen, and then we kind of go from there. Hey, can everybody see that? Yeah? Yeah? Cool. All right, awesome. All right, so just a quick kind of primer here. I'm sure you guys have all played Among Us, right? This is kind of the sensation that has swept the nation and also was part of this year's WebLab video. But you know, a lot of other games exist as well, like we've seen, like Minecraft, League of Legends, even Gather could be considered a game. So all these kinds of platforms are called games, but you might wonder like, okay, these are so different from what we've been learning in WebLab so far, right? Because everything we've learned in WebLab so far is like, you have Chatbook, you know, it's like a feed, and then you have like profiles and stuff. And games are just so much more complicated. But to be honest, I think a lot of what you guys have learned so far really is pertinent to games. And there's only some small things that we have to add on top to really, you know, make your games really good. So today we're going to be talking about that. And in particular, it's going to be a very, very, very brief TLDR, because you could learn a lot about games over, you know, many, many weeks, and we don't have time to cover a lot of that. So we're going to be trying to, you know, take the essence of game development and what you should watch out for when you're building your own games and kind of squash that into an hour, right? So we're going to be glossing over a lot of things. There's going to be a lot of skipping and kind of mushing over some concepts, but I'll be available afterwards to answer questions, and there's always Piazza with your wonderful staff. So let's get started. And I'm going to open up chat here so that I can make sure I can answer any questions you have. All right, sweet. So let's talk about games. So what really makes these real-time games so much different from Chatbook, right? Well, the first thing is that there's a lot of really complicated logic that goes into games, right? So for Among Us, for example, you have, you know, who's doing what task, who killed whom, who's an imposter, who's not an imposter, which location you're in, all this stuff, right? And games also have a ton of really performance needed graphics, especially some games that are like real time, such as you can see here, League of Legends, right? There's all kinds of random nonsense going on. How do you render all of this, and how do you make sure your computer doesn't crash because, you know, you don't want to have to make all your users buy super powerful computers just to play your game, right? So these two are the pillar stones on which we kind of say games are a little bit different than what you guys have been learning so far. And we'll be diving a little bit into these today. Great. So let's talk about a little bit about what you guys have learned so far. Right. So this is kind of a diagram that might be a little bit familiar to you. Right. So you have a user, and it authenticates with some backend, which is your Node.js server in this case, right? And then I think WebLab, we've been teaching you guys MongoDB as your database that backs up all the backend. So that's all good and dandy, but what do we have on top of that to support our games? Well, there's game logic and game state. And this game logic and game state lives in the backend. So it's going to hang out with all the other stuff that you've been writing for your API and things like that, right? And most importantly, that I want to emphasize is that game logic and your game state need to live in your backend, okay? They cannot live in your client. So if you're going to take something away from today and our discussion that we're going to have, is that if you're writing a game and you have logic, all right, it needs to go in your backend, okay? And the reason that is because if your game logic and state is held in the client, that's on everybody's computers, right? So if you have 100 people in your game, then you have 100 versions of what's going on in your game, And that's super not chill because everybody kind of needs to see the same state in order to play the game together, right? This would be the equivalent of if you're playing a board game and everybody has their own board, and then they have to like move their own pieces on their own board every time something happens. That just doesn't really work, right? So we need some central place where all this logic and state lives, and that's going to be our backend. And second, we could talk a little bit about graphics here. So as you guys saw on that earlier slide, right? Some games are very, very performance intensive. There's all kinds of stuff going on. How are we going to draw that, right? How are we going to make sure all that is being rendered to the screen so users can see it? Well, in our case, we're going to be using something called HTML Canvas. And I think you guys might have talked a little bit about it on one of the other sponsor lectures, but we're going to dive a little bit deeper into exactly what HTML Canvas is and give you a brief overview. So what really is HTML Canvas? Well, if you dive into it, an HTML Canvas is essentially just any other HTML element. So you guys learned about like divs and stuff like that, right? An HTML Canvas is just another one of those elements, except it has a special property that you can call this canvas and draw things on top of it. Like you can draw shapes, you can draw letters, you can draw images, right? You can draw whatever you want. And it's really, really fast at drawing these things. Super duper fast, right? And then if you draw really, really fast many times in a row, it can start to look like whatever you're drawing is like animating, right? So as you can see here, this ball kind of looks like it's like moving, right? But really what it's doing is Canvas is just redrawing over and over and over and over again until it looks like it's smooth, right? And this is not really something you do with React. React is like very static, right? When you update something, things change. But if you're going to update the React like 60 times per second or something like that, it's not going to be a great time. It's not going to be a great time. Right? So we normally would like to use Canvas for these kinds of renderings just because it's more efficient. And that's what we're going to use today. Cool. So diving a little bit deeper into this, you guys are probably familiar with this like XY coordinate plane, right? That you guys learned in like middle school or 7th or 8th grade or whatever. But in Canvas world, it actually looks a little bit different. So this is what your coordinate plane looks like on Canvas. So the top left is 0, 0 instead of the middle. And this is kind of weird for games because, you know, this means that if you increase your Y, you're moving downwards, right? Whereas most people would think of like, okay, if you're increasing your Y, you're going to move up, right? And we'll see later how we deal with that. But this is important to keep in mind because if you guys are ever using Canvas in your own games to draw things and you're like, everything's inverted, what's going on? I don't know. It's because 0, 0 is on the top left. So if you guys are drawing, you have to keep this in mind, okay? Great. So this kind of gives us the intro into the technologies we're going to be using today. Let's take a look at actually what we're going to be building during this workshop together. So here's kind of what we're going to be building. You can see it's a little fun, super fun game where you and everybody else in the same game as you guys are all little circles. And what happens here is you're trying to find the hidden spot in the world that is like the goal spot. So there's like this hidden spot that everybody's looking for called the secret spot. And every single circle is just like looking for that spot. So you're using your arrow keys to navigate around to find it. And the closer you are to the spot, the more blue your color is. And the further away you are, the more red your color is. So it's kind of like, you know, that hot and cold game you guys played when you were kids, except on the internet, right? So let's watch one more time. You can see as you get closer to the actual spot itself, the color of your circle gets more and more blue until you finally find it and declares a winner. Okay, declares a winner. Cool. So that's what we're going to be diving into today. That was like a very, very fast 10-minute TLDR of everything that we're going to be covering. And I want to stop really quick for you guys to ask some questions. So is anyone completely lost so far? Give me like thumbs. Usually I ask for thumbs up, thumbs down. We're in a lecture hall, but can't do that over Zoom. So if you have questions, let me know how you guys thinking. Anybody confused so far? No? People following along? Good. Give me a thumbs up. I can't see any of the thumbs up, can I? I'm like in a slide. All right, whatever. I'm just gonna take the sample of the 6 videos that I can see and use that as my guide. All right, cool. So let's kind of dive into it. It's gonna be a fun workshop. So let's build it together. If you guys go to weblab.to/color-hunt, you're gonna clone a brand new Git repository. Now, before anybody starts cloning, I want to make sure that you guys don't clone into your Chatbook repository, okay? Because this happens way too much. So if your terminal says Chatbook, you're in the wrong place. So you know, cd space ... get out of Chatbook first. All right, get out of Chatbook, and then you can clone your repository. Because if you clone it within Chatbook, staff is going to get mad at me. You know, we're not going to be able to sponsor next year. It's not going to be fun. So don't clone inside Chatbook. All right. So and then I'll also do this with you guys, so that so I'm going to type in web.lab.to/color hunt. Right. Cool. Very nice. You can see that I just finished the starter 35 minutes ago. That's a good time. All right, so we're gonna click code, and then we have a URL here. We're gonna click that copy button, right? And then let's see. Then I will example clone this. So I'm gonna make sure that I'm not in Chatbook, all right? And then I'm gonna type git space clone, and then paste that URL. Cool. All right, and then now I can cd into color. Cool, and now I have a bunch of stuff. Okay. Cool. So give that a go. Give you guys a little bit of time to do that. If you need help asking the questions, Doc, I guess. Remote school is pretty hard, isn't it? You know, like when we were doing web last year, people could just run around and help, but you know, can't do that over Zoom, unfortunately. Okay. Can you guys see this okay? Yeah. Okay. All right, and then once you're done with that, you guys can git checkout starter, and then do basically the same thing you guys did with Chatbook, right? It's npm install, and then you're gonna want to run npm run hotloader, and then a tab do npm start. Cool. I'll give you guys like a minute or so to do that. And then once you're done with that, throw me a thumbs up and I'll try to see who's not done yet. All right, so just a little bit more. If you're having trouble with that, make sure to ask staff. And then if you run this correctly, you should go to localhost 5000, just like we do in whatever, you know, your Chatbook or your React skeleton, and open up the app and you should see it running. Now, quick to note, I did build this thing off of the React skeleton that staff has so wonderfully provided you guys. So if you want to kind of take a look at it and then build off of it, that's fine as well. But you know, it's not a very aesthetic game, so. Okay. So as you guys are finishing up that, we're gonna, before we start to get to coding, I'm gonna kind of walk through what this structure of everything looks like so far, so we're all kind of on the same page, right? And you guys can keep cloning in the background if you're still working on that. So here's what we have. Here's some context for what's going on behind the scenes here. This might look kind of familiar to you guys, right? The client socket, server socket stuff. You guys just learned socket today, is that correct? This morning, yeah. So we're still kind of getting used to it, but essentially the client socket is the socket like, you know, port on the client side. The server socket is the socket like port on the server side. They're kind of like bus stations, right? And then you send messages across these two. And then you can see that in React land, we have a skeleton, which is just the default name for the base component. I haven't changed that. And also we've added two more components. This game component, this login component. Now login, as its name suggests, will handle everything to do with logging in, and the game component will handle all like the kind of game updating, the game rendering, things like that. Okay. And now we're going to add a few more things in here. The first is a canvas manager. So we spent a good amount of spiel talking about canvas earlier. Canvas manager, its only job is to just draw things to the canvas, right? So you have something to draw, canvas manager will draw it for you. And we have a file called input.js, and input.js is just in charge of keystrokes. So like, typing and stuff, if you ever use your arrow keys, input will know, right? So this is a file that I've written for you guys that kind of takes in input from the user. And then finally, we have a file called logic.js. Logic.js is on the server, and that handles running all of your game logic, right? So everything from, the actual internals of the state to like what happens when people move, et cetera, et cetera. So all your logic should go in there. Okay. Cool. So that's kind of the architecture here. You can see that what happens when you send a input. So if somebody decides to push their arrow keys, what will happen is input.js will catch that, send it to client socket. Client socket will be like, great, it's a new input, and send a socket message from the client to the server. Then the server will say like, oh, this is a socket message that has to do with the game, so I'm going to let logic.js handle it. Logic will take care of that movement and stuff, and then it'll send back some new state, right? Some new state. So you can see there's like a division of labor here. So logic takes care of keeping track of all the state updates that are happening and all like the movement that's happening, et cetera. And then input will take care of actually getting the input from the user and sending it up to the server to handle. Now I'll mention that this state, this game state that I'm talking about, it's very distinct from this React state that you guys have been learning about. Right? So React state is what we use to update the React DOM. Game state lives on the server. It's kind of like whatever you define it to be. It has nothing to do with React. It's just something that we're calling what's going on currently inside the game and what we're sending back to people. All right. Right. So everybody should have the same version of game state. Cool. All right. So you might ask, like, okay, Alex, this is great. There's division of labor here. So people are, adding inputs, and that's changing the game state, and the server is updating that game state. But then how does everybody, like every single person who's playing my game, know what the current game state is, right? So, what is going on inside the game? Well, what we actually do is inside of our code, and this is not, you guys don't have to write this, I've taken care of this for you, is we just spam the client with game updates all the time. So 60 times per second, you're just sending the game update to the client. You're like, here's a game update, here's a game update. Even if it's the same, you just blast them with game updates. And this is just the simplest way to do that, right? Because you don't have to ever worry about your client being out of sync, because 60 times per second, it's getting updates and updating itself accordingly, okay? So that's how we're gonna deal with this for now. It's kind of inefficient, but more to come on that. So what this looks like in our new model is 60 times per second, you're just throwing updates back at the client, right? Cool. So now you gotta ask yourselves, okay, so we have this idea of a game state, we have input. So what should be in this game state? So I've put together kind of this little fun multiple choice question here for you guys to look at. So what do you guys think should be in the game state, right? Out of all these things. And remember, the game state is kind of like, what does everybody need to know about what's going on in the game? Right? What does everybody need to know? So what do you guys think? Vote now in the chat. I don't know. Yeah, you guys are totally right. And this is one of those questions that professors put on to like make sure everybody's listening. But yeah, like it's all the above, right? It's the classic, didn't want to make too many complicated options, so just made an all of the above. So yeah, it's all of these things, right? Everybody needs to know the color of the player, the locations, and whether anybody won. So in a second, what we're gonna do is we're gonna spend some time to code this up, okay? Cool this up. All right, any questions so far on this setup? Because I think we're almost ready to get started on our game. We're almost ready. Any questions? And staff, if there's anybody who's asking pertinent questions in the questions doc, you feel free to send them to me on Zoom as well. Okay. All right, so let's get started. Where is my VS Code? My VS Code is over here. So everybody's going to open up VS Code and open up this project in it, and we'll get started with the coding. So the first thing that I want you guys to do is go ahead and you guys can all see my screen, right? Yeah. Is this too small, too big for everybody? Is this good? Good size? Can everybody see it? It's tiny. Okay. Good. Oh, that's a contradictory statement. All right, I'm gonna make it a little bit bigger. All right, cool. All right, so let's see what's up here. All right, so what we're gonna do, and by the way, guys, it's completely optional for you to follow along this workshop. If you prefer just to listen to me, please do that. In fact, I might encourage it because there's a lot of coding that needs to be going on. Can I get a link to your slides? Yeah, of course you can. Let's see. Where are my slides? Where are my slides? Over here. I'm gonna send out slides on the Zoom. Cool. All right, so let's take a look. So first thing we're gonna do is everybody's gonna type Control or Command P, and then type logic.js. All right, you guys remember logic.js, our old friend, right? So what does logic.js do? It keeps track of all the game logic, all the game state, everything goes in here, right? So this is like probably the most important part of our game, okay? And the first thing we're gonna do is we're gonna initialize this game state here, this game state, right? So what goes into the game state? Well, we just decided, right? We just decided there are a few things that go into the game state. So first is whether there's a winner, right? And I'm just gonna call this winner. You guys can call it whatever you want, but I'm gonna call it winner. And we're gonna set this field to null because at the beginning of the game, nobody's won yet, right? Everybody's kind of just still in the lost stage. And then we want to keep track of every single one of our players, right? And I'm going to make this a JavaScript object. I'm gonna make it a JavaScript object, okay? And so what this is gonna be is it's gonna be ID to color to an object with color. So we're gonna have color, and then we're gonna have X and Y. We're gonna have color, X and Y. So that's all we need to know about every individual player. So when you guys make your games, it's very likely that you'll need to do something like this, where you have a players dictionary somewhere or object, right? Keeps track of where everybody is. Cool. Wouldn't it be an array of objects? Yeah, that's a good question. So instead of an array of objects, we want to keep it an object of objects so that we can have like a key to value mapping. So now we can access, like, those of you that are my 6 presentation, you know this, like you want to O of 1 access, right? So if it was an array, you have to like iterate through every one. That's annoying. So we prefer to have it be an object in this case, right? So now that we have this, the next question is, okay, when are we going to update this? When are we going to update this game state? Okay, so what actions? Let's brainstorm together, guys. Let's take a second to think. When do you guys want to update this game state? Like, what actions are going to happen on the front end to make you update this game state on the server? Any ideas? Any ideas? Yeah, keys pressed, good. Keys pressed, someone wins, very good. So any kind of movement, right? And new player joins, good. New player joins, good. Right, so all this stuff. There's one more that we're missing. One more that we're missing is actually when a player disconnects too. Because if a player disconnects, you want to boot them out of your game state. Otherwise, you're going to have like ghosts floating around. And this is generally not a good thing, right? So first thing I'm going to do is I'm going to show you guys how this is done by us. Let me watch my slides. Where are my slides? There's. So in here, this is a file under server socket. Don't go looking for it. It's fine. You don't ever need to look at this ever again. But inside server object, this server socket, there's a function called add user. Add user. And this is what happens when a socket like connects to the server. And in our code, we've added logic.addPlayer in here. That makes sense, right? So every time a new socket connects, we're going to call this add player function in our logic that will update our game state. So what does that mean concretely for us? That means we have to implement this add player function, right? So how are we going to implement add player? Well, so glad you asked. So what should happen when a player gets added? Well, you want to update your game state, right? So game state.players of this ID, we're first going to give it a random location. And I've written a function for you guys that will get a random location from that. Okay, so just grabs a random location. So what this does, it says, hey, I'm going to grab a new player, and then I'm going to give it some random location anywhere on the map, right? Anywhere on the map. And then I'm also going to give it its color. Dot color, right? And then I've also written another function called get player color. Now, I know, I'm kind of just like glossing over all these things, but you guys can go look at it after the workshop. Unfortunately, we only have an hour, so I don't have time to get super into the depths of how we're updating these locations and colors, but I've written the utility functions here, right? So essentially what we're doing is we're getting a random location and then updating that color to make it work, okay? Cool. So what this does is it just adds a new player, right? So now whenever a new player comes in, they should be able to, get a random position, location, and a random color. And then we also want to be able to remove players, right? Same kind of logic here, but instead of, we want to change the game state, right? So how are we going to change the game state? Well, we can just delete game state.players ID. Right? So what that does is it's just going to take that ID and just punt it out of the object. You're no longer in here, right? Because we don't want any IDs who are no longer connected to our socket to be in our game state. Cool. All right. So I'll give you guys a second to process that. So we've just added the player and removed the player. Okay. So now the next thing we're going to do is we have our game state and it's on the server and things are great, right? So players are getting added, players are getting deleted, everything's awesome. But right now our canvas isn't drawing anything, right? So our game is not playable if our canvas isn't drawing. So what we're going to do now is we'll go press Control or Command P and go to game.js. Game.js. Right. And you can see here that I've written a function called socket.update. This dot process update. So what that's doing is every time we get an update from the game server, we're gonna update our game state somehow. We're gonna update that, right? So how do we do that? Instead, in here, we're gonna call a function called draw canvas update. And draw canvas is a function that we're going to define in 1 second. Okay, so we're kind of working forwards here. So draw canvas hasn't been implemented yet, but we're going to implement it in just a second. And what draw canvas does is it's a function in Canvas Manager. Okay, so we're in game.js. We have draw canvas and process update. We go to Canvas Manager. Actually, we'll go back. So Command or Control P, Canvas Manager. And you can see we have a function here called draw canvas. Right? We have a function here called draw canvas. And what draw canvas is going to do is, well, it needs to draw the players and where they currently are, right? That's the main kind of meat of our game, is where all the players are, right? So when we're drawing all the players, we do, and I'm going to type this out and I'll explain it in a second, so don't get too overwhelmed. Okay, we're going to do object.values of our state. And then for each one, I know this is a lot. I wish I had a buka to explain all this, but unfortunately I don't. So I'm going to type all this really fast, and then I'll explain what it's doing in a second. Okay, so this is a lot of code, but what does it do? What does this do? So object.values draw state players is it takes the draw state and the players inside that draw state. Remember, in our logic, we have an object called players, right? So that's just accessing that players object. And it's saying for every single player that you have under that object, we're going to do the following. We're going to draw it. Right? And how we're going to draw it? We're going to call a function called draw player on the X value, the Y value, and its color. Does that make sense, everybody? Yeah? Make sense? So this is just kind of a bunch of syntactic sugar for saying iterate through all the players, draw each one. So now we actually need to implement the actual draw itself, right? We need the actual draw itself. So what I've done is I've implemented a function called fill circle for you guys. And what this does is it takes in an X, a Y, a radius, and a color, and then it'll draw that. It'll draw that, okay? But here's our problem. Remember earlier when we were talking about this whole like canvas versus like real life nonsense, right? So our problem right now is that we're drawing in real life coordinates, but we actually need to convert it to canvas coordinates first, right? And Juliana asked a great question that I'll get to in a second. So what we're gonna do is we're gonna create two variables called draw X, draw Y. And we're gonna call a function called convert chord, very creative, which converts the coordinates from real life coordinates over to canvas coordinates, and then fill the circle using canvas coordinates. Because remember that earlier diagram we had where canvas is like the zeros at the top left, but in real life it's in the middle, right? That just makes that conversion. All right, so let's talk about context. What's context? Context is just like a property of this canvas element. Remember, canvas elements are just HTML elements, right? So they're just like kind of like a div, but more fancy. Whenever you want to draw something on a canvas, you need to pass in the context, because the context is the object on which it's drawing stuff. It's like a good way to think about it, right? And you can read more about the documentation of this later, but essentially every time you want to draw stuff, you need to use the context to draw it. So we need to pass it around everywhere, and it's kind of clunky. Okay, cool. That was a lot of what we're doing today, is just this one pipeline of logic and then game and canvas, right? You guys see the kind of thing here. If you guys only gonna take this is the most important part of this lecture and workshop, is you have kind of many sections, and each has its own realm. So logic deals with logic. It sends that down to game, and then game calls canvas, which draws everything, right? So every file has its own responsibilities, and as long as we keep these files separate and keep them doing what they're supposed to be doing, you're golden. You're golden, right? Cool. All right. So let's see if I made any typos. I think, right. So let's try this thing. So if I go to localhost 5000 and I log in, and I'm using the Chatbook auth because I was lazy. Let's see. There we go. Now you have your player here, right? And you can't do anything with it yet. All it does is it draw out the player. But honestly, this is most of the work, right? Now you've set up these three sections of logic, and then the actual React stuff, plus the canvas, and everything else is just filling in the blanks. Just filling in the blanks, right? So when you're designing a game, this is the kind of setup you want to have, logic and canvas, right? But yeah, we've been able to draw a circle so far. So great work, team. All right, I'm gonna take a quick pause for questions, because I know we just went through a lot. How's everybody feeling? Okay so far? Yeah. Everybody who wants to build a game is like, I'm ready. Let me go, Alex. I'm gonna go do it right now. I'm ready to build Among Us right now using circles. Cool. No questions so far. Everybody following along okay? Yeah. All right. So great. So if you guys want to catch up, we're gonna do where's our slides? Over here. So you can get reset hard, and then check out step 1 if you want to catch up to where I am right now. Cool. Get reset hard, and then check out step 1, and then we will keep going. We'll keep going. All right, we're doing okay on time. Good work, team. All righty. So I'm gonna go back into VS Code, and we're gonna work on the next thing. So next step. All right. So we have everything spawning. There's stuff that's drawing, and your guys are like, Alex, I'm tired of hearing about logic and canvas, but you guys are gonna keep hearing about it, right? Now we're gonna start dealing with movement, right? And I have a file called input.js that you guys can go look at after this workshop, which deals with all the keystrokes and stuff. We're not going to touch that file right now because it's not going to fit within the hour. Okay, but what I'm going to have you guys do is trust that eventually what happens is the logic gets to here, this move player function inside of logic, right? So what happens under the hood here is when you press a keystroke, input.js catches that right? It catches it, and then it sends it to the server. And the server is like, whoa, it's a movement. What do I do with a movement? And you're like, wait, Alex taught me that I should put it in logic, right? So then we wrote a function inside logic.js, which handles moving players. And what should this do? It should update the game state, right? Because once we update the game state, everybody else knows about it. So how do we do that? How do we do that? And you can see that it passes in a direction, up, down, left, or right. So if our direction is up, right? If our direction is up, what do you guys think should happen? What do you guys think should happen, right? So, oh, I see some of asked questions. I'll answer these in a second. So yeah, so if you're gonna go up, how are we gonna access this particular player that we want and change their position, right? What do you guys think? What do you guys think? Right, so y should definitely change, right? Remember, when you're in your logic, it's not in canvas coordinates, it's in normal coordinates. That's why we have all that convert chord nonsense, right? So up is actually y increasing, right? Because you want 0, 0 to be the center, right? You guys can define it other ways, but this is usually the most intuitive way, is like up means y goes up, right? So that means we want to do game state dot players of ID. Actually, let's make this a little bit easier, and we just do, we're first going to get our player, which is, it's just game state dot players of ID, right? Can't type. So what that's doing is it's just getting the object that is our player, and then we're going to say player dot y plus equals 20, right? Plus equals 20. So what that's saying is, hey, in the game state, let's find this particular player that you're trying to move and change their y by 20. That's all you need to do to move, right? It's because we have this really nice setup here of logic and canvas. Right? Okay, so let me look at some of these questions. How do you pass position to the client? Right, so the position and the game state in general is emitted to the client all the time, right? 60 times per second using the socket. So the client is always aware of these position updates. HTML5 graphics only apply to browser games, right? Yeah, exactly. So things like StarCraft, Fortnite, all this stuff, they use much more advanced things. Canvas is like a simple in-browser solution. Yes, so since we're converting on the React side from normal coordinates to canvas coordinates, we can deal with like normal coordinates here. I like to do that because logic can get really complicated and you don't have to think about like, canvas coordinates are this way, right? So you just deal with it when you're drawing. That's the easiest way. So let's fill in everything else. And some of you guys might already started doing this, but you know, if dir equals down, like what's up, right? Well, player.y, you probably want to take away 20. I don't know, I chose 20. What do you guys want to do? You guys want to do 20? I feel like 20 is easiest, so I've just been doing 20. And then if it's left, what happens? What do you guys think? What should go here if you're moving left? Vote now in the chat. Yeah, good job. So player.x minus, look at you guys. You guys are game experts already. Don't even need to teach you guys over Zoom. All right. Oh, I don't know how to type. All right. Right. And then we're gonna add on 20. And that's it. That's literally it, right? So you guys see how simple games are once you just say, all I'm doing is I'm updating the game state, right? So if we go over, let's see how good my coding is. Let's see how this went. And look at that, we can move, right? So you guys should be able to move in your own games as well, which is pretty sweet, right? Cool. Cool. All right. You already said this, but how do you make sure a player doesn't go off the grid? That's a great question. You don't in our game. Right? So players can go wherever they want in our game. It's great. But the great thing about this is that you guys, the game designers, can do whatever you want. Do you want players to be able to go off the grid? If so, then don't worry about it. If you don't want them to go off the grid, right, you probably want to check in move player if they're going off the grid. And if they're going off the grid, you're like, no, stop, right? Because this is logic. So all logic should go under logic.js. It's a great question. Great. So now we've managed to make everybody move. That's pretty sick. So now we just need to change the colors. And what we can do here is we can do the exact same thing that we used to do, which is that player.color equals get player color, right? Which is how we did the original initialization of the color. We're just re-changing it now to update whenever we move, right? Because every time you move, your color is going to change. Your color is going to change. Yeah, exactly. So to answer the question about how do we check if chords are off the board, you can just check inside logic.js, right? Cool. Alrighty, so let's see how our game is doing. Hit that nice refresh button. Go log in using Chatbook because I'm lazy. And look at that, your color is changing. Oh, so pretty. So pretty. All right, this is a complete web project. I'm turning this in for credit. Cool. All right, so that's nice. Great. All right, so you will fail the class. That's very mean. Nick, you are so mean to me. All right. All right, let's move on. So if you want to catch up to where we are, okay, you could check out step 2. All right, cool. We're doing great on time. So anybody have any other questions? You guys basically built the game already, right? Come on. You have circles and they're moving around. What else do you want out of the game? Cool. So go ahead and check it out. No personalization. Yeah, I guess that's true. Cool. All right. So let's do the next thing. So we're almost done, guys. Honestly, we're almost done. You guys have been doing a great job. So the next and last kind of thing that we need to do is there's currently no win state, right? There's no way to win. How's that going to work? Right. So we need to actually be able to check whether somebody is going to be able to win or not. All right. So how are we going to do that? How do we do that? Well, handily enough, I have a function called check win, right? And what check win should do is we want to figure out whether anybody has won or not. So how do you guys figure out if somebody has won? Let me know in the chat. How do you know if somebody has won? What is our definition of winning in this game? Do you guys remember? We talked about it earlier. Yeah, their location is the goal. Exactly. Yeah, you can either check the color or the location. Checking the color is actually an interesting idea. So if you're entirely blue, then I guess you win. That's a good also a good approximation. But yeah, I think the most straightforward way is like, look, let's just check if they are on the goal, right? And handily enough, we have a function, we have a thing up here called const goal equals get random location, right? So we can just check under logic.js whether or not you've hit that goal. So let's do that. So I'm going to do some funky nonsense here with object again. So object.keys. What does object.keys do? It just iterates through the keys of the object. So all the IDs of each player, right? So what this is going to do is it's going to output a list of all the players. And then for each one of those, for each like ID, I guess, I'm going to call it, yeah, we can just call it the ID, right? What do we want to do? Well, first, let's get the player out, right? So const player equals game state players of ID. Right. Okay, so what we've done here is we're literally just iterating through every single player because that's how we're going to check if anybody hit the goal. And we get that player. And if we say if player.x equals the goal and player.y equals the goal, right? Then what do we do? What do we do? How do you guys want to update the game state? Any thoughts? Remember, our game state looks like this. Right. So this. Yeah, good job, guys. Excellent. Yay. Yeah, so we're gonna set the winner, right? We're gonna set the winner. Yeah, so inside this function, we say excellent. We say game state dot winner equals this ID. Because that's the person who won. If they're on top of the goal, they've won. Now, here is a really important point. If this logic lives on the client, like lived on your browsers, right? Each one of your browsers, and everybody could check the winner. You could just win by changing this code on your client, changing that logic, and then you would automatically win, right? So you could just like straight hack it if you want, like a hacker man, right? Oh, so cool, right? But no, it's the developer's fault for putting game logic on the client. That's why we don't do that. We don't do that, right? This is why it's so important that your logic is on the server. Cool, so now we have a winner, which is pretty sweet, but we need to check when we're winning, right? So when do we need to check win? That sounded weird. At what time do we need to check win? Like what could change to change a winner, right? So how often do you guys want to check win? Yeah, so there's a few proposals here, right? And you could do either one. You could either check every frame. So you could just be like, I'm constantly gonna check for winners all the time, right? But if you think about it, the only time anybody ever is gonna win is when somebody moves, right? So we can actually just do it in here. In move player, right? Because if that player moves, we can just check the win. We can just check a win, right? Does that make sense, everybody? So two ways. I think the more performant way is just to check every time somebody moves, right? And then you're almost done. You're almost done. So now you have a winner in the state, right? So the logic part is taken care of. So what's left? If we've already finished the logic part, right? What else do we have to do? Last part of this game. Yeah, that's right. That's right. So we need to display on the client, right? As Daniel said in the chat, right? Excellent. So we need to somehow show the winner. And, you know, I've already done a lot of that for you. So we're going to Command or Control P, game.js. Okay, game.js. And you can see here that process update is kind of the pipe in which all updates flow, right? So what we can do in here is we can say, if we got a winner, from the client, right, we can this dot set state your winner to update dot winner. So what this does is it tells React like, hey, if you got a new winner in the update, so somebody won the game, you should tell everybody, right? You should tell the client that somebody won. So we set the state here. That makes sense, everybody? Okay. Cool. So let's give you guys a second for that. Nice. All right. So once that's all through, let's see what we're looking at, shall we? So we go back to our coolest game ever. Go ahead and log in, right? And nothing happened. What's going on here? Is our client broken? Ah, cannot convert undefined. Oh, wait, yeah, okay. We need to restart. Ah, so we made a typo. That's excellent. So go back to logic.js. I think this should be gamestate.players. Yeah. I don't know how to type clearly. This used to say gamestate.player. All right, now let's try again. Let's try again, see if this works. If that works, yay. Okay, so where is this thing? I'm really bad at my own game, by the way. Somewhere around here? Somewhere over here? I don't know. No? All right, I don't know. I'm bad at this. Oh, there we go. Okay. All right. Great, cool. So we found our secret square, right? And you guys can too on your own computers. And the great thing is this supports as many users as you want, right? So anybody can connect to your game and you guys can all play this color hunt game together. Excellent. Great work, team. All right. Get good. All right, what do we have in the chat? What if you never hit the goal? Right, so you have to account for this in your game logic. So what the question is like, what if we're ever jumping by 15 or something like that and you can never hit the goal? Yeah, so you need to account for this in your game logic, right? So a few ways you could do it. You could either be like, okay, if I'm close enough to the goal, somebody wins, right? Like maybe I'm within 20 from the goal. Or you could be like, hey, I'm only gonna jump in increments of 20, and then I'm only gonna set the goal at increments of 20, and then you're also good. I think we went with the latter in this approach. Right now we're updating at 6 times a second. Is it possible to update at 6 times per second only when someone's keys are pressed? Yeah, you can do that. So a lot of this game is by far and large not great, that good of a game, right? It's not terribly fun, and we're doing a lot of things like constantly spamming updates that we don't necessarily need to do, but it does give you guys a starting point to start out on how to set up this logic, right? And as Nick said, it's lots of work, right, to actually do this the right way. All right, cool. So if you want to come to where we are now, you can get checkout main, get reset hard and get checkout main. And you should be with us at the completion of the game. All right, so that's the completion of the workshop. You guys did great. We blasted through it, finished developing a game within 40 minutes. Pretty fast stuff. So proud of you guys. I'm excited to see all of y'all's games. So what did we learn today? Let's take a really quick recap and kind of go over our thoughts here, right? First things first, game logic, where does it live? I'll give you a hint. It's not on the client. All right, so game logic always lives on the server. All right, so if I see anybody's games that has game logic on the client during judging, I'm auto-failing you. No, I'm just kidding. I will not auto-fail you, but I'll be very sad. So game logic always goes on the server, and we'd like different technologies to draw this game. Like you can do it through React, but generally like Canvas or something else is a better choice. Okay, so great work today, everybody. It was great to come in. I'll give you guys like a 2-minute spiel on Gather, and also send the jobs board out to you guys. So Gather, right now we're a startup that's, I mean, you guys know what we do because you guys used our product for milestone 1, but we're actively hiring for software engineers, product managers, all kinds of roles. And as we're also thinking of starting an intern program, but we're not 100% sure yet. But anyways, come chat with us and feel free to come learn more if you'd like. And I will send out the jobs board on the chat. How do I stop screen sharing? Oh, here we go. Cool. And yeah, if you guys have any questions about anything, I'd be happy to answer them, whether it's related about the workshop we did or the work we do at Gather. And I will send out the jobs board momentarily. Here's our jobs board, by the way. I think, oops, I sent that to Claire. I don't know if Nico, you guys have a place you guys are putting jobs boards for sponsors, but feel free to throw ours up there if you'd like. Great. So that's about it. Does anybody have any questions or anything about the workshop? Ah, put on Piazza. Thanks. That'd be great. Cool. I guess I just did a really good job of explaining everything and everybody just completely understands and there's no holes in the comprehension. I dig that. I dig it. I dig it. How do we start the game? Yeah, so our current game is set up so that if you find the goal once, you can't unset the winner. So now you have to restart your server, which of course is not ideal for a game. So we're gonna have to find some way that you like add some user interface element, right? That that you click and then that should reset the winner, reset the goal or whatever. And then you guys can go find the goal again. How do you handle lag connections? Yeah, that's a great question. So right now in our game, we have no handling of laggy connections, right? Like everything, if you just lag, you'll just be disconnected from the server and you won't get any updates and you won't get any like anything at all, right? How games deal with this is, how a lot of games deal with this is they do like client-side prediction. So like predict where the player is going. So even if you're gonna be lagging a little bit, at least the client will be like, oh, this person was moving this way, so they'll probably continue to move that way, right? And then how do you add players to see your same game? Right. So once you deploy this, it's like Chatbook, right? It's exactly the same as Chatbook. You can open 2 tabs on your localhost, like one in Firefox, one in Chrome, and play against yourself if you like. But you know, in the future, when you guys build out your games, you can just create a website for it, and everybody can come into the same game and it'll work. how did you decide to start? Oh, Jason asked like rollback. I'm not sure exactly what rollback is, but maybe if I'm understanding what that is. How did you decide to start GatherTown? Okay, so before I get into that, we have an engineer and somebody early at GatherTown here. Her name's Amy. Amy, where are you at? Are you around?
Hello.
Hi. So Amy also works with me at Gather, so I had her come as well in case you guys had other questions. Nico, how do you want to do this? Should we like set up 2 breakout rooms for questions, or do you want to kind of just do it all in one? Like whatever you guys want to do.
You can do it here if you want. I don't know if Claire or Kai have an opinion. We just moved to the breakout room so that way you could give your lecture here, but
okay,
you can
yeah,
do it
sure.
here if you want.
Yeah, so I can answer how we decided to start Gather. We started Gather right when quarantine started. And in the beginning, it was kind of just a fun project that a bunch of friends put together. You know, I staffed web.lab for a while, so you guys know that I like building fun things like web projects. And we kind of just threw it together, and then people seemed to really like it, and it started making enough to justify bringing it into an actual business. So that's what we did. So it was never intended to be like a huge business or anything. It was more like a fun thing for us to try running around a virtual world. And I guess it's stuck on ever since. So we're very lucky to have had that. Yeah. How was it like when you created it? Yeah, I guess similar question. Yeah, it's been pretty fun. It's been a lot of learning. Lots of janky code, as Shannon knows. Shannon was also working with us for a while. So. Do you guys have other questions? Okay, let's see. So let's go through this one at a time. If logic should be on the server, how does Google No Internet Dinosaur Game work? Yeah, so Google Internet Dinosaur Game is a 1-player game. So if it's a 1-player game, then whatever. But actually, the Google Internet Dinosaur Game is really easy to cheat. Like you could very easily cheat on the dinosaur game. You probably give yourself infinite points if you wanted to, because all the code is like client side, right? So that's kind of the answer. If you want multiplayer games that prevent cheating, you need to have it on the server. What was the hardest thing to code and gather? I'll let Amy answer that. What's the hardest thing you worked on, Amy?
I guess working. So we are working on this desktop app for Gather. There are a few parts of it that were I guess like tricky with like audio video stuff and making sure that I guess there's like this mini window thing that pops up when you're on desktop apps. So you kind of feel like you're persistently in a space and can always see a preview of what's going on around you. And so there are some tricky things that are going on there with like videos muting or like audio muting unexpectedly and then having to debug that. I think it's always just like debugging that's challenging, but also fun once you like kind of discover or like figure out what's going on in the what's going wrong. Yeah. Alex, what was like the hardest for you?
Probably performance.
True, yeah.
As you guys can tell from our workshop today, like our workshop is very not performant. Let me tell you, like, you're blasting updates to the client 60 times per second. It's like very bad, right? I think Gather sends 20 updates per second instead of 60 or 24, I think. But we do a ton of stuff on the client to make sure that you're not doing extra work. So for instance, you can, if the update hasn't changed, we literally do nothing. So you like check if the update changed anything and you're like, okay, if it changed nothing, then let's not do anything. And we have a system where it sends like diffs instead of the whole state so that, it doesn't blast the client. All kinds of problems like this are really hard to deal with. Why can't Gather handle screen sharing to 200 students? I don't know. I'm not on the info team. Don't ask me. No, my understanding of the video code is that it's just like too much bandwidth for one DigitalOcean droplet to handle. So it's not able to be done right now. Zoom is crazy, by the way. You guys, Zoom is insane. Zoom stitches all the videos together in the back end, like on their servers, and then sends it to you as one stream. Instead of sending you like 100 streams, it sends you one stream. It's crazy. Some crazy stuff they're doing on Zoom. It's completely nuts. Have you ever considered building Among Us and Gather? Yeah, this is in the works. It's in the works. We don't know when it's going to be out. We're working on a system right now that will let you do like build arbitrary games inside of Gather. So it includes like, and this is like not anywhere close to being deployed yet, but we're experimenting with like player-to-player interactions and then external game servers that allow you to, like, anybody can build a Gather game and then plug their Gather space into their Gather game engine. And then now their Gather game engine handles all the logic for them. And then we literally just render everything for you. So I'm very excited for that. Like Minecraft, exactly. So our vision here is that your Gather spaces should be more customizable than Minecraft spaces. Like, I want you guys, like, we should be able to do pretty much anything in the Gather space. Like, you want to build Among Us, like, go crazy, right? But that's the dream, and I think we have a few folks working on that right now. One of our really interesting problems that we're hoping to get soon. How would you find people to work on Gather with at the beginning of other projects? I mean, I just work with my friends, I guess, and then Amy, you can take this opportunity to pub Hack Lodge if you want.
Yeah. I guess like all the co-founders were part of this community called Hack Lodge. It's this program where pre-COVID times, we ran like week-long hacker house type of program where we'd bring together like 20 or so undergrads. It ran in like the winter and the summer in various cities, and we would, I guess, like just spend a week hacking on a project in teams. And I also participated in Hack Lodge one summer and started doing like some organization stuff too. And that's how I learned about Gather too at the start. I remember Philip sent out this email to the mailing list and told us like, oh, they're like, that Gather was looking for people to join and help work on the product. And I was also simultaneously introduced via a mutual friend. So that was also kind of really cool to see circles kind of coming together and be able to meet new people too through this Hack Lodge community. And other than that, do you want to talk about other recruitment efforts?
Yeah, so like Daniel and Akshat were saying, like Hack Lodge is super cool. If you guys are interested in that, you should reach out to them because it's a super fun experience. And I guess a lot of our, like in the beginning, a lot of it's just working with your friends. I think if you guys want to get a product started, just work with your friends and build something cool, right? Don't worry too much about things in the beginning. Like, I feel like I worried a bunch of stuff in the beginning that just wasn't even relevant at all. Like, you're just gonna build something cool and then like, just build it for the sake of building it. And then I guess past that point, a lot of it was, very intentional recruiting, reaching out to different communities, reaching out to you guys here at web.lab to kind of get people who are interested in web projects and beyond. Cool. And of course, you guys are free to go, by the way, if you want. I mean, it's 2:02, so feel free to go. I'll say a closing statement that I'm really excited to see all your guys' games and websites, and I'll try to drop by the hackathon to kind of say hi to y'all because I miss web.lab. So
yeah, can we get like a virtual applause for Alex and Amy and Gather? Yeah, thanks for joining us. Just a couple of closing announcements. We have a hackathon this Friday. It's not like a competition type hackathon. It's more just like office hours on steroids. So if you're working on your project or if you're stuck on your milestone, definitely come to office hours. And then also subscribe to our YouTube channel so we can start monetizing and go through every single video. And if you like it, we'll give you bonus points at your evaluation. Yeah.
What?
But other than that, I think that's all we have for today. Yeah, thanks everyone.
Thanks everybody. I'm gonna stick around for any other questions you guys have. But feel free to hang out or whatever, and I'll see you guys all at the hackathon.
You can't judge our shameless plug, Alex.
Yeah, true. You guys should just plug. All right, take care, guys. I'll see you all at the hackathon.
Yeah, thanks, Alex.
Yeah, of course. If anyone else has any other questions, I'll stick around for a little bit. But feel free to also drop off and do whatever.
Wait, I have a question.
Sure.
Hi, Alex.
Hi.
How are you? Yeah. How is it like creating a startup? Like, was it like how did you start? I guess like to learn about the business side of things.
That's a great question. I didn't handle too much of the business side. Our CEO did a bunch more of the business side of things. But there's so much to learn about. Like, startups are kind of weird, like startup valuations, like raising money, all this kind of stuff we never had any exposure to. So we kind of just stumbled our way through. The biggest advice I have about doing a startup, especially on the business side, if you're an engineer, like you're coming, like all four of the founders of Gather are all engineers. So the most important thing is you build an interesting product and then you get advice. So you find people who already know what they're doing inside the industry. For us, this takes the form of a lot of angel investors who want to put in money and like get a small percentage of the company. And they like kind of help us like understand, okay, when should we be raising? How should we raise? All this kind of stuff. And that really helps us kind of, get started. And everybody's journey is a little bit different. So I think most important is talking to a lot of people who already have experience to get a sense there. It's hard to come in with a lot of experience.
I see. Yeah. Wow, that's really cool. Thank you so much.
Yeah, of course.